So picking up right where we left off, looking at the graph for number 2, let's talk domain and range on that graph, okay? Remember, your domain values are your x values, and when we think about this parabola, and we think about the x values visually, that means left and right, does this parabola, even though it's going down, doesn't it continue to go to the left and to the right forever? Yes? Okay, so that means that x equals all real numbers, because it really does go to the, even though it's going down, it goes to the left and to the right forever. Okay, it keeps going out. That's exaggerated, but it keeps going out. Even numerically, when you think about the inputs, well, I plugged in 1, 2, 3. I could plug in 4, 5, 6. I could plug in 10. I could plug in 1,000. I could plug in 1,000 right there into the x. I'm going to be able to get an output, right? So technically, my domain is all real numbers because I could plug in any number I want, okay? So I explained it visually. It goes left and right, keeps going left and right, goes out forever, even though it goes down. And even numerically, you could plug in 1,000, you could plug in negative 1,000. You could plug in any number you want. So x is all real numbers for the domain. Now the range, on the other hand, your range are your y values, okay? Now your y values are going up and down. Like this is the y value of 5. Does this graph exist at the y value of 5? Yes or no? Does the parabola ever touch the y value of 5? No. Does it ever touch the y value of 4? No. Does it touch the y value of 3? Yeah, it exists at the y value of 3. It exists at the y value of 2, at the y value of 1, at the y value of 0, negative 1, negative 2, negative 3. So what are your y values of this graph? All your y values have to be less than or equal to 3. And that's your domain and range for this particular parabola. Okay, so let's move on and continue graphing the rest of these guys. Number 3, and let's not worry about domain and range right now. On number 3, let's do the vertex. How do you do the vertex? You're going to do x equals negative b over 2a. Your a value is 2, your b value is negative 8, and your c value is 5. So when we go to find the vertex and use negative b over 2a, we're going to be plugging in negative 8 for b, and we're also going to be plugging in 2 for a. So when we work this out, we're going to end up with positive 8 up on top over positive 4 on the bottom, which means that our x value is really 2, right? Our x value is really 2. Our x value of what? Our x value of our vertex is really 2. So once you have the x value and you want the y value, what do? You plug it in. Plug it in where? Into the original equation, quadratic trinomial equation. So I'm going to take this equation, y equals 2x squared minus 8x plus 5, and I'm going to rewrite it down here. But instead of x's, I'm going to put parentheses. That way I could plug in my 2. Check it out. There it is. Y equals 2 parentheses squared minus 8 parentheses plus 5. Instead of x's, I put parentheses. And I'm going to plug in this 2 right in there and in here. Now that I've plugged in the 2, let's work it out. We're going to do exponents first. 2 squared is 4. So we're going to have 2 times 4, which is really 8. And then you're going to have this negative 8 times 2. That's going to be negative 16. And then I'm obviously going to bring down the plus 5 at the very end. So from left to right, 8 minus 16, that's negative 8. And negative 8, bring down the plus 5. That will give us a negative 3. Now what is that value? That's the y value of our vertex. Y equals negative 3. So the vertex y value is negative 3. Now we have the complete coordinate for the vertex, 2, negative 3, 2 comma negative 3. So let's actually graph that vertex, the most important point of this parabola, 2 comma negative 3. So let me go 2 on the x, negative 3 on the y. This is my point, my vertex. Through that vertex exists the axis of symmetry. I want to draw a dotted line right here in green, just to show that reflection line. That's called the axis of symmetry. And now we already know that that's the axis of symmetry. We just need more coordinates. How do I find more coordinates? XY table. That's right, XY table. Okay, so let's do the XY table. Let's plug in an easy number. What's the easiest number to plug in? 0. Okay, so let's plug in 0. And what do we get out? Whenever you plug in 0, it makes it 0, except for your C value. That's going to end up being your answer, right? 0 squared is 0, 2 times 0 is 0, 8 times 0 is 0, 0 take away 0 is 0, 0 plus 5 is 5. Super easy to plug in 0 because that's just going to give you the answer. That's your C value at the very end. So let's do 0, 5. So 0, 5 is going to be way up here at the edge. And which other number would be nice to plug in? 1 would be good. So let's plug in 1. And when we plug in 1, let me zoom in. So I rewrote it right there. 2 parentheses instead of x squared minus 8 parentheses instead of x plus 5. Let's plug in the 1 that you guys just told me to do. 1 squared is 1 times 2 is going to be 2. So we have a 2 right there. And then 8 times 1 is 8, but with the minus sign. So you have 2 minus 8. Bring down the plus 5. So 2 minus 8, that's negative 6. And negative 6 plus 5 is negative 1. So my output's going to be negative 1. So when I plug in a 1, I get out a negative 1. And that is another coordinate right there. So let's go to the graph and graph the coordinate 1, negative 1. We end up right here. And now we could actually map both of those coordinates to the other side of the axis of symmetry. So this top coordinate that's at the edge, it's 2 units away, right? 1, 2. Go 1, 2 this way and put a dot right there. The next coordinate is 1 unit away, so go 1 unit this way and put a dot right here. And of course, we already have enough coordinates to draw this perfectly nice parabola. So when you draw the parabola, please put arrows at the end because it shows that it goes up forever. Not only that, when you come down, even though this is very narrow, don't make it look like a V, even though you might want to because of the word vertex. But since we know it's a U-shaped curve, it has to curve at the vertex, has to curve at the vertex, okay? And that's our graph. Let's do number 4. Number 4, again, to find the vertex, you're going to use negative b over 2 times a. Our b value is what? What's our b value? 1. So we're going to plug in 1 for b, and the a value is what? What's the a value? You can see it right here. It's 1/2. So let's plug in a 1/2 right here. Let me zoom in to do that. Plug in a 1/2 right there. And now we could actually work this out. Negative 1 over, what is 2 times half? That's just 1. So you really have negative 1 over 1, which the answer is just negative 1, right? So our x value of our vertex is negative 1. Once you have the x value, let's find the y value. How do you do that? By plugging it back into the original, okay? So I already rewrote, if you could see it here, I rewrote this quadratic trinomial equation down here, but instead of x's, I put parentheses. Now let me plug in the negative 1 right in there into both of them. Let me zoom in and plug in negative 1 right in there. So when we work this out, negative 1 squared, that's 1. We still have the times 1/2 right in front of it. And we still have the plus, and that becomes a negative 1, so plus negative 1 minus 3. So what is 1/2 times 1? That's just 1/2. And then you have plus negative 1 minus 3. So plus negative 1 minus 3. If you go 1/2 plus negative 1, that's just going to be negative 1/2, correct? So we're going to have negative 1/2 minus 3. What's negative 1/2 minus 3? Negative 3.5, or negative 3.5. Are you with me? So the y value of the vertex, this one gets nasty because you don't end up with nice numbers. You end up with negative 3.5 or negative 3.5. I'm going to go with negative 3.5. So on our vertex, let's go to the point negative 1, negative 3.5. Negative 1 on the x, negative 3.5, that's halfway to the negative 4. So let's put a dot right there. Let me zoom in a little. Make that dot nice. Okay, so there's my vertex. Now through the vertex exists the axis of symmetry. So let me draw an axis of symmetry. And of course, we already know that this parabola opens up. Why do we know it opens up? Because the a value is positive, even though it's half, it still opens up. We need more coordinates, so I'm going to jump to an XY table. The easiest number to plug in is 0. So when I plug in 0, what do I get out as an answer? -3. That's right, the C value. So let's go to 0, -3, which is right there. Map it over to the other side, you're right there. This is too small of a U-shaped curve to leave like that. Okay, so we need more coordinates. What other number could I plug in?
1.
I could plug in 1. But you know what? Thinking about this, 1 squared is 1, and then times half, I want to get half. Yeah, I could do that. Or I could go for 2, because if I plug in a 2 right there, 2 squared is 4, and 4 times half, that's a nice number 2. Right? So let me plug in a 2. Let me first zoom in and replace the x's with parentheses. And let me plug in a 2 right there. So when I go 2 squared, that's 4, and 4 times the half, that's going to be 2. And then I have plus 2, but then take away 3. 2 plus 2 is 4, take away 3 is 1. So when I plug in 2, I get out a 1. Does that make sense? So let me graph the coordinate 2 on the x, 1 on the y. And of course I could map that over. That's 1 unit, 2 units, 3 units, 1 unit, 2 units, 3 units. And ladies and gentlemen, that's enough to complete our parabola. That's an ugly parabola, I apologize. But that's it. That's a good graph right there. I hope this helps, and I want you guys to try the other 4. As a matter of fact, you could skip the first one, okay? That's a freebie. You know why you could skip it? Because it's the same exact one as the one over here that we just did. Typo, my bad. Yeah, so you can skip number 1. All you're doing is numbers 2, 3, and 4 for homework. Go for it. Have fun. Enjoy.